Hello, this is Mr. Flatness, and today we're going to be focusing on dividing decimals by decimals. Dividing decimals by other decimals follows the same pattern as traditional long division. However, what we want to do is add a couple of steps beforehand. And so here are a couple of steps that I want you to write down in your notes. The very first thing we need to do is take a look at when we're dividing, we need to multiply the divisor by a power of 10 so that it becomes a whole number. That's the biggest step that you have to do when you're working with dividing decimals by decimals and long division. Your divisor has to be a whole number. So, and basically all you're really doing is you're sliding the decimal so that the divisor becomes a whole number. Then the second step is then once you've multiplied the divisor to make it a whole number, then you're going to do the exact same thing to the dividend. You're going to multiply that dividend by the same exact number as you did the divisor, and then you will just finally traditionally divide like what we did in the previous lesson. Here are two examples where we're going to divide decimals by other decimals. So the first thing we need to do is rewrite these problems because I do not want a decimal as my divisor. Again, to review, the first number in each of these two problems is the dividend, which goes on the inside of the brackets. The second number that you see is the divisor, and that goes on the outside of the brackets. The diagonal line here is saying divided by. So I'm going to rewrite 1.71 divided by 0.9 in traditional format. So 1.71 divided by 0.9. And now I want to go through and take a look at how can I get rid of the decimal in the divisor. That's step one. I have to change 0.9 into a whole number. In order to do that, I need to slide the decimal one place to the right. So I'm going to take this decimal and I'm going to move it over here. So the new decimal is right after the 9 right there. Okay? So 0.9 into 9. Well, basically what I did was multiplied 0.9 by 10 to get 9. So whatever I do to the divisor, I have to do to the dividend. So I'm going to take this decimal and I'm going to slide it one place to the right. So my new problem now becomes 17.1 divided by 9. And now I can use traditional division to solve for that. So I'll select my hand tool here. I'll shrink this down so that I have some room to write. So I'm going to do 17.1 and I'm going to divide it by 9. And I'm going to use the algorithm, again, does McDonald's serve cheeseburgers? That's what I'm going to use. So divide, multiply, subtract, check, and bring down. Just looking at this, I should get an answer right around 2 because I know that there are 2 9s in 18 and 17 is really close to 18. So I'll move my decimal straight up in my answer. 9 goes into 17 only one time. Now I'll multiply. 1 times 9 is 9. I'll subtract and I get 8. Check. Is my answer that I get after subtraction smaller than the divisor? If so, I can proceed. After the check, I'll bring down the 1. 81 divided by 9 is 9. And 9 times 9 is 81. I'll subtract and I get 0. So therefore my answer is 1.9. And I know that I'm pretty certain that that's correct because when I estimated I said that I should get an answer right around 2 and 1.9 is very close to 2. In the second example we had 5.94 divided by 0.2. 5.94 divided by 0.2. So again, what I'll need to do is move the decimal to make the divisor a whole number. So in this case, I'm going to slide it over one place to the right. So therefore, I need to do the same thing to the dividend. So my new problem becomes 59.4 divided by 2. So then what I'll do is divide using the algorithm. I'll divide, multiply, subtract, and bring down. So 2 goes into 5 2 times. 2 times 2 is 4. I'll subtract. 5 take away 4 is 1. I'll check. 1 is smaller than 2. I'll proceed. I need to now bring down the 9. 2 goes into 19 9 times. 9 times 2 is 18. I'll subtract, and I get 1. Again, I'll check. 1 is smaller than 2, so I can proceed. I will bring down the 4. And then I'll ask myself, how many 2's go into 14? Well, that's a basic fact of 7. So I'll put a 7 above there. One thing I forgot to do is put the decimal straight up in your answer once you've gotten it correctly placed. Again, also notice that I'm lined up too. My answers are right above the numbers. So now I can move on to multiply. 7 times 2 would be 14. I subtract and I get 0 as a remainder. So therefore 29.7 is my answer. And when I look at it, is it right? 59 is close to 60, and 2 times 30 is 60, and my answer is 29, and 29 is close to 30. Therefore, I know that my answer seems reasonable. In this example, I have 8.1 divided by 54 thousandths. So I'll rewrite that by going 8.1, that goes on the inside, divided by 0.054 or 54 thousandths. Now looking at this, if I want to change my divisor into a whole number, I have to move the decimal place now not once, but 3 times. It needs 3 places. So moving a decimal to the right 3 places is actually multiplying the number I have here by 1,000. So I will do that, and I'll rechange it, so I'll put a red decimal in here for the new decimal. So that decimal moved 3 places, therefore now I need to have this decimal and the dividend move 3 places. Well, if you see and notice here, to move it 1 place, now I'm at the end of the number, so if I want to move it 2 more places, I have to add on 2 more zeros. Now I can have it a total of 3, move the decimal a total of 3 places. So that's how you would set up your problem. So now then your actual problem that you can divide out would be 8,100 divided by 54. And it's the exact same problem, it's just written differently. The other thing I can do now is, because I have a double-digit divisor, I can use estimation a little bit and think, well, 54 is close to 50, and that will help me in my division a little bit. So 50 does not go into 8, but it goes into 81. So there's roughly 150. So now I'll multiply. 1 times 54 is 54. I'll subtract, and I get 27. I'll check. 27 is smaller than 54, so I can proceed by bringing down a 0. And then again, I'll look at, well, how many 50s get me close to 2? Well, here's 270, so 50 and 250. I think about that. There's 5 quarters. There's a way to think about it. So I'm going to try 5. So 5 times 4 is 20. 5 times 5 is 25, plus 2 is 27. So there it worked out where I have 0 as a remainder. I have 1 more 0 to bring down. Well, 54 does not go into 0 except 0 times. So that's my answer there. I'll put the 0 up there. Also, I've forgotten to put the decimal point out on the end and move it straight up. So there it would be. I have no more numbers to bring down. So then I know that 150 would be my final answer. In this next slide, we have some things that deal with algebra a little bit and algebraic thinking. We're moving towards that in the 6th grade. So here are some terms I want you to write down in your notebooks. We have numerical expression. And basically a numerical expression is any time you're going to add, multiply, subtract, or divide. Anytime you're doing that with numbers, that's just called a numerical expression. I have numbers and it's telling me what to do to them. An algebraic expression would be a combination of variables and operations, okay, where a variable is just a letter of the alphabet, x and y, a and b, z and x, y and n. And then you just need to look at the symbols here. So I wrote down some different ways to kind of talk about add, subtract, multiply, or divide in some cases. So here I'm just going to add whatever x is plus whatever y is. Here this is another way to say a times b. Z minus x and y divided by n. Okay, and again that variable is simply a letter of the alphabet and it can represent any number that I assign to it. Please again write these down in your notebooks because you will need to have these memorized. So here are a couple of problems that you would use using these algebraic expressions. So in my first example I have a divided by b. Well, you'll notice up here I've assigned now the letters to specific numbers. So if I want to know what a divided by b is, I know that a is 4.9 and I know that b is 0.7. So a divided by b would be the same thing as 4.9 divided by 0.7. In the next example I have a minus b divided by b. So in that case, again, I know that a is 4.9, b is 0.7, c is 5.6. So I'm going to rewrite this as 4.9 minus 0.7, and then I'm going to divide that all by 0.7. So let's set those up and solve. I'm going to shrink this down so I have some room to write. So, looking at the first one, 4.9 divided by 0.7. Again, I got to take the fractional or decimal divisor and make it a whole number. So I'm going to slide that one place to the right. Do the same thing with a dividend. Put the decimal point straight up in the answer. So now it's 49 divided by 7, which I know is 7. 7 times 7 is 49. I'll subtract and I get 0. No numbers to bring down. My answer is 7. In the next example, I have 4.9 minus 0.7 first, and then I'm going to divide that by 0.7. So the first thing I'm going to do is take 4.9 minus 0.7. So again, I'll line up the decimal points because it's subtraction. We're going to subtract first here because I need to know what is the actual number here up on the numerator. Well, I don't know that until I subtract these two first. So doing that, 4.9 minus 0.7 is going to be 4.2. So now that I know that, what I can do is I can shrink that down and continue solving by taking 4.2 now and dividing that by 0.7. Slide the decimal over one place to the right this time, one place to the right here. 7 into 42 is 6. 7 times 6 is 42. 0 is the remainder. No number to bring down. 6 is my answer. So there's a couple of different problems where I'm going to use algebraic expressions to solve. Nothing really different in terms of the computational pieces, those things we've been doing. Now it's just looking at it a little differently, looking at letters for you to plug in numbers. Here's a problem for you to try on your own. Write it down, solve it, and then press pause. After you've solved it, press play, and then you can check the solution. Francisco made $357.25 last week. Aaron made $185.30. How many times as much money did Francisco make as Aaron? Round to the nearest tenth. So a couple of pieces of important information. The money that they each earned. Looking at how many times as much, well, there we're going to look at the division. How many times as much talks about dividing, even though you see the word times in here. And then finally, rounding. We need to round our answer to the nearest tenth. So there's a lot of things in here that I need to do. So first thing I want to do is set up the problem. So doing that, I'm going to give myself some room here to write. And so that's going to be 357.25, 25 cents. And I'm going to divide that by $185.30. Now I'm going to proceed by rewriting the problem by moving the decimal points. I need to move this decimal point in my divisor 2 places to the right. So if I do that to my divisor, I also have to do that to my dividend. So I will rewrite my new decimals. So they need to be, and I'll put them in blue. So there. And then move this 2 places there. I'm going to move it straight up in my answer. Now this is a big problem with big numbers, so estimation here is very important. So here I've got a number that looks like 18,530. So I'm going to, in my brain, I'm going to think about roughly 20,000. Because then I can work with 20s. 35,725 is very, very close to 40,000. So now it helps me with my division. How many 20s are in 40? Roughly 2. But because I've rounded up my divisor more than my dividend, what I'm going to do is I'm going to keep it at 1, even though there's 2 20s in 40. We're going to keep it at 1. And then we'll see after multiplying whether or not we need to adjust. So multiplying that out, I should get 18,530. I'll subtract. And I get 17,195. And when you look at it, when I check it, this has to be smaller than this, and it is, so therefore I know that I did it correctly. So I know that it's going to be a little over 1, but if you also take a look, remember it says we need to round to the nearest tenth. So notice right now, here's my decimal point. Well, the tenths place is to this side of the decimal point, which right now I don't have any number there. So I need to add in placeholders. So I'm going to add in a 0 and extend the division problem. So then I need to bring that 0 down and now redivide. So now I'm looking at 18,530. How many of those go into 171,950? Again, huge numbers. So use estimation. How many 20,000s go into 180,000? Well, here I didn't adjust that number very much, so I think what I'm going to do is 20s into 180s, 2 into 18, I'm going to use 9. So then I'm going to take 9 times 18,530, and I'll get 166,770 after multiplying. I'll subtract, and I will borrow. And get 5,180. I'll check it. Is 5180 smaller than 18,500? Yes. So now I got the number in the tenths place, but that's the number I want to round. So in order to round that number, I need a number to the right to know if 9 moves up 1 or if it stays the same. So what I need to do is add one more 0. And again, I can add zeros as many times as I want, bring it down, because that's not going to change your number. So the final one is going to be 51,800 divided by 18,530. Again, I'll use estimation. This is roughly 50,000, and this is roughly 20. So 20 into 50, I'm going to choose 2. And so then I'll take 18,530 times 2 and get 37,060 after multiplying. Subtract and I get 4,740, which is smaller than my divisor, therefore 1.92 is accurate. And now I can round. The 2, because it's 4 lower, will not change a 9. So now my answer then becomes 1.9 rounded. And then to answer the question, how many times as much money? 1.9 times more, because Francisco made more than Aaron did. So that would be the answer to my question. And roughly when you look at it, is 357 a little more, about 2 times as much as 185? Yeah. So I know then that my answer is acceptable. This concludes the lesson on dividing decimals by decimals.